This is our factoring test review part 2. All right, on number 10, definitely a greatest common factor problem. They look like they have a 3 in common and an x. You can go ahead and write the factors on top if you need to. I'm just trying to get the review finished, so I'll go ahead and write down that they do have a 3x in common all the way across. That's going to leave behind a 6x squared, a minus 7x, and a plus 10. Now, even though it looks like it might factor a little further, I'm going to multiply. It's going to be a type 2 if it factors further. I'm going to write down the factors of 60. 1 in 60, 2 in 30, 3 in 20, 4 in 15, 5 in 12, and then I think, ooh, that's it, right? They have to be able to add up to a negative 7x. So I'm thinking, okay, I could make the 12 negative and the 5 positive, but do they still multiply out to be a positive 60? No. So at that point, you're finished. Now, this part is prime, but we don't have to write that because this problem actually factored. We were able to take a greatest common factor out. This number 12 is very similar, but so let's look at that next. Number 12, I can see that all the numbers are even, so I'm going to take a 2 out. I can factor, let's see, I've got 5x's, 3x's, 1x, 3y's, 2y's, 1y. So it looks like I can take a 2xy out of everything. When I factor the 2xy out of the first term, it's going to leave behind a 2, an x to the 4th, and a y squared. When I factor the 2xy out of the second term, it's going to leave behind a 4, an x squared, and a y. When I factor the 2xy out of the last term, I'm going to be left with a plus 5. And that's finished. So number 10, number 12 are just greatest common factor. Now, this number 11, it is a 2-term phrase. It's got a squared term, so already I'm thinking it's a difference of 2 perfect squares. The base being squared in the first position is a b. The base being squared in the second position is a 7a. So I'm going to open up my 2 parentheses. Remember, difference of perfect squares factors into a 2 by 2. Our first base goes in our first position. Our second base goes in our second position with a plus and a minus between them. Again, pause me or stop if I go too fast. On number 13, it is a trinomial. I looked to see if I can factor it out and I can't. So it is going to end up being a type 2, which means I'm going to multiply the 25 and the 4 together. That's 100. I need factors of 100 that I can make 20 out of. Some of you will immediately think 10 and 10. Or you can write all of the factors out. But once you find that 10 and 10 are going to work, I'm going to make them both positive because I need them to add up to a positive 20x. Now rewrite it. 25x squared. I'm going to rewrite the 20x using those two numbers, plus 10x plus 10x plus 4. Now we can factor by grouping. 25x squared and 10x have a 5 in common all the way across. And an x, don't they? So I'm going to factor a 5 and an x out of both terms. When I factor the 5x out of the first term, it leaves behind a 5x. When I factor it out of the 10x, it's going to leave behind a 2. Bring down the plus sign. 10x and 4 both have a factor of 2 in common. When I factor it out of the 10x, it's going to leave behind a 5x. When I factor 2 out of 4, it leaves behind a 2. Now I'm down to 2 terms. If I factor the greatest common factor of 5x plus 2 out of both terms, it does leave behind another 5x plus 2. Now that's the answer, but I have another really neat way that I can write it. If I have 2 of the same factor, you are allowed to write the answer as a perfect square that way. So either one of those is correct. And finally, last one over here. It looks like a cube, but the 2 is not. So then I think, well, maybe that's the greatest common factor. 2x cubed and 54 both have a 2 in common. When I factor it out, I am indeed left with x cubed minus 27. That is a difference of 2 cubes, a cube problem. So I'm going to start off by identifying what's being cubed in each position. Remember, cubes factor a little bit larger than a square. They factor into a 2-term and a 3-term phrase. The first base goes in the first position, second base in the second, with the same sign as in the original problem. The trinomial we will build. The first base squared goes in the first position. What is x times x? The second base squared goes in the last position. What is 3 times 3? 9. This is always a plus. This sign is opposite of this one. And the middle term is our first base times our second base. And this one is always prime at that point. Now let's go ahead and keep going. We're going to solve. This one is already completely solved for us, so I'm just going to set each of the factors equal to 0. I'm going to move the 13 over to the other side, so I'm going to get x is equal to negative 13. I'm going to isolate the x's on the second one, and I'm going to move the 3 over. So I get 2x is equal to negative 3. After dividing both sides by 2, we will end up with an x of negative 3 halves. On number 17, I'm going to start by getting everything on the same side and equal to 0. I get x squared. When I move the negative 5 over, he becomes a positive 5x. Now this one is kind of strange looking, but I want you to remember your factoring skills. First thing you do is always look to see if they have anything in common. These two terms both have an x in common. I can factor it out of the first term. I can factor it out of the second term. Now that we've got it completely factored, I set each factor equal to 0. This one is solved. It says x equals 0. It is okay to get an answer of 0. Now I'm going to move the 5 over to the other side, so my answer will be x equals negative 5. Let's keep going. 2x squared, 12x, and 10 are already all on the right side with and in descending order, set equal to 0. So I'm looking now and I'm thinking, you know what? They all have an extra 2 in common. So start off by factoring out the greatest common factor. When I factor the 2 out of the first term, it's going to leave behind an x squared. When I factor 2 out of 12x, it leaves behind a 6x. When I factor 2 out of 10, I'm left with 5. Now that's a type 1, so immediately I'm going to go ahead and open up my 2 parentheses. Don't forget to bring that one down. Factors of 5, 1 and 5. I need to put the signs in so that the two numbers add up to positive 6. So they'll both be positive. So now factors of x squared are x and x, and the factors of 5 I want to use are plus 1 and plus 5. I'm going to, now that it's completely factored, I'm going to set each factor equal to 0. That doesn't mean anything. This is going to give me an x of negative 1, and that will give me an x of negative 5. Number 19 is super nice. It's already completely factored for us. So I'm going to start by setting each factor equal to 0. I'm going to move the 5 over first. Remember, anything that crosses over the equal sign becomes the opposite sign, so it's going to make it a negative 5/3. After dividing both sides by 3, we're going to get x is equal to negative 5/3. Next, I'm going to move the negative 7 over to the right to get those x's isolated. We're going to get 2x is equal to 7. Now, to get the x solved for, we're going to divide both sides by 2, so I'm going to get an x of 7 halves. Number 20. Let's see, it's already all on one side set equal to 0, but that is a difference of perfect squares, isn't it? I've got the difference, that's an x that's being squared, and that's a 7 that's being squared. That factors into two-term phrases. First base goes in the first position, second base goes in the second positions with a plus and a minus between them. To solve, I'm going to set each factor equal to 0 and then solve for x. To solve for x here, I'm going to move the 7 over to the other side. That gives me an x of negative 7. To solve for the second x, I'm going to move the negative 7 over. That gives me an x of positive 7. I'll see you in the next video.